So hello guys, welcome to the channel. So we are starting with PyTorch fundamentals. Before going deeper into deep learning, we will first learn PyTorch fundamentals, and we are starting with PyTorch introduction today. Okay, so let's make a basic understanding today. What is PyTorch? Okay, so PyTorch is an open source machine learning and deep learning framework developed by Meta. Okay, it is used to build and train machine learning and deep learning models efficiently. Okay. PyTorch provides a simple, flexible, and Pythonic way to create neural networks. Okay. It uses tensors with multi-dimensional arrays as its fundamental data structure, similar to NumPy arrays. Okay. PyTorch supports GPU acceleration, automatic differentiation, and dynamic computation graphs, making it powerful and easy to use. Okay, simple. It is widely used in research and industry for computer vision, NLP, reinforcement learning, and many other AI applications. Okay, that is the basic things about PyTorch. Okay, now let's see what are the things we can build with PyTorch. Neural networks, ANN. We can build basic neural networks for classification, regression, and prediction tasks. Okay, that is what ANN do. ANN deals with your tabular data set like Excel and CSV. Okay, and second one is your computer vision model. We can create models for image classification, object detection, segmentation, face recognition, and many more. Okay. Third one is your natural language processing, NLP. We can develop applications for sentiment analysis, text classification, translation, and summarization, and many more. Okay. So using PyTorch. Fourth one is your LLMs, large language model. We can train from scratch the large language model, or we can fine tune at the existing LLMs for creating chatbots, AI assistants, text generation, and code generation. Okay, using PyTorch. Fifth one is your speech and audio applications. We can build systems for speech recognition, voice assistance, speaker identification, and audio classification. Okay. Sixth one is your recommendation system. So we can create recommendation engines or movies, products, music, videos, and many more using PyTorch. Seventh is your time series forecasting. We can forecast future values for stocks, sales, weather, energy consumption, and other time series data. Okay. Eighth one is your reinforcement learning. We can build intelligent agents for games, robotics, self-driving cars, and decision-making systems using PyTorch. And ninth one is your generative AI application. Generative AI, generative new content. We can generate new content such as images, text, music, videos, and code. Okay, using PyTorch. Last one is your research project. So PyTorch is widely used with respect to TensorFlow in AI research, academic projects, and Kaggle competitions. Okay, so that is all about what we can build with PyTorch. And next is your what are the features in PyTorch? Okay, it is open source. It is completely open and source and free to use. Developed by Meta. I already discussed. Pythonic and easy to learn. So it has simple and intuitive syntax. It feels like writing normal Python code, making it beginner friendly. Okay. Third one is your tensor based. So it uses tensors as the fundamental data structure. Tensors are similar to NumPy arrays, but with GPU acceleration. Okay, which makes it faster. By the way, this is our next topic. Okay, so don't worry about practical part. In this video, we are basically taking a basic understanding about PyTorch. In the next video, we will cover it practically, tensors, what are optimizers, autogrid, and all the things we will cover practically, and then we will move forward to deep learning using PyTorch. Okay, so don't worry about practical part. In this video, I'm just giving an overview. Okay, so fourth one is your dynamic computation graph. So it builds the computation graph dynamically during runtime. Okay, provides flexibility and makes debugging easier. Okay. Fifth one is your automatic differentiation. It automatically computes gradients using AutoGrad. Okay. simplifies backpropagation and saves time. All these things we will see autograd backpropagation practically. Okay, so don't worry about it. Sixth one is your GPU acceleration. It supports NVIDIA GPUs using CUDA. Okay, it speeds up training significantly and handles large models efficiently. Okay, it is basically GPUs using CUDA. CUDA is basically for your making your operations faster. Okay. Seventh is your rich neural network library. It provides torch.nl with pre-built layers, activation functions, loss function, and more to build models easily. Okay. Next one is your efficient data loading. It provides a dataset and data loader utilities for efficient data loading, batching, shuffling, and multiprocessing. Okay. Ninth one is your, it has a strong ecosystem. It comes with domain specific libraries. Means Torch Vision will be for computer vision. Audio will be for your audio processing. Torch Text will be your for your NLP, and Torch Metrics for your model evaluation. Okay. Tenth one is your tenth and last one is your easy deployment. We can deploy on web, mobile, cloud, and edge devices using Torch Script, ONNX, and PyTorch Mobile. Okay, these are the features of PyTorch. Now, let's see how we can install PyTorch. Okay, now let's see how we can install PyTorch. Okay, all you need to search here is pytorch.org, and yeah. Here in PyTorch build, you have to select stable. Okay, it is default selected, and your OS, whatever OS system you have, you need to select according to your OS system. And my OS is Windows, so Windows will be selected. It is default selected, and package will be your pip. Language will be Python, correct, and CUDA will be your 12.6. It is correct. CUDA is for basically for making your operations faster. Okay, so uh, before that, you must have Python installed in your system. Okay, so all you need to do is copy this command. Okay, and first please select your OS system according to your OS. Okay, and just search here cmd, your command prompt. Okay, and just paste your command here, click enter. In my system it is already installed, so it is showing requirement already satisfied. Okay, so this is how you can install PyTorch in your system. Okay, but make sure you have already installed Python. Okay, so that's all in this video. In the next video we will discuss PyTorch tensors. Okay, practically. So that's all in this video. Thank you. So hello guys, welcome to the channel. Today we are going to discuss tensor in PyTorch. Okay, so a tensor is the basic data structure used in PyTorch. Okay, so a tensor is a container that stores numbers in one or more dimensions. Remember, in one or in more dimensions, it can store the numbers. Okay, so if you have already used NumPy, you will understand a PyTorch tensor is very similar to a NumPy array. Okay, but tensors are designed to work efficiently with deep learning and GPUs. Okay, for example, I have a single number. This is a zero-dimensional tensor. I have list of numbers. It is a one-dimensional tensor. I have a table with rows and columns. Okay, it is a two-dimensional tensor. And now if I have multiple tables. Okay, now multiple tables can form a three-dimensional tensor, and so on. For example, if you can see, I have here like let's say three tables, and it is forming three-dimensional tensor. Okay, so this is what tensor is. Okay, now why are tensors important? So almost everything in a neural network is represented using tensors. Okay, a tensor can hold data of any size and in any number of dimensions. For example, input data tensor. It can hold images also. Okay. So here you can see I have input data as a tensor. The features of all training examples are stored in a tensor. Okay. Image is converted into 3D in the tensor, height into width into channels. Okay. Weights. Okay. All learnable parameters means weights of the model are stored in tensors. Okay. Bias. Here you can see bias is also in tensor form. Okay. Predictions, your prediction final output, your losses, your gradients, all are the things will be stored in your tensor. Okay. So this is why the tensor is very important. Okay. Now let's see tensors practically. Okay. First of all, we will import our PyTorch by import torch. Okay. Import torch. It will take some time to load. Okay. Now let's say let's create some tensors. Okay. Uh, let's say I will give a markdown here. Creating creating tensor. Okay. Creating tensors. Okay. Now let's say I will use empty first to create a tensor. Okay. Let's say I have created a variable t1 is equal to torch dot empty empty. I'm using empty for creating my first tensor. Let's say I'm giving 5. What it means? Okay. So basically, empty tensor, it will basically not fill any values. Okay. Empty tensor, it will not fill with any specific values. It will basically contain, it can contain 0. Okay. So this will create a one dimensional tensor containing 5 elements. Okay. I have written 5 here. It will contain 5 elements. Okay. If you will see your T1, here you can see. It will not give you a specific value. It has given you 0, 0.0, 0.0. This is how it is looking. Okay. If you will check the data type of your first tensor, it is float. Okay. Now, let's say I want to make same tensor, but with integer data type. Let's see how we can do it. T2 is equal to, let's say I'm creating a new tensor, torch dot empty. Again, again I will give 5 elements. And now what I will give D type torch dot int. Okay, because I want the same tensor with integer data type. Okay, now if you will see your T2 dot D type, here you can see int, right? Now let's create three-dimensional tensor using rand. Okay, so let's say I'm creating a let's say I'm creating a new tensor T3. Let's say torch dot rand, and I will give something like 5 comma 4 comma 3. Now what it means? Now it will create a three-dimensional tensor containing numbers between 0 and 1. Basically, torch.rand creates a tensor filled with random values, okay, from a uniform distribution between 0 and 1, okay. So here I have written 5 into 5 comma 4 comma 3 means if you will multiply this 5 into 4, 20, 20 into 3, 60, you will get total 60 elements, okay. 5 means 5 such matrices, 4 means we will have 4 rows, and 3 means 3 values in each row. Okay, this is what it means. If you will print your T3, it will something look, it will look like this. Okay, now, now let's create a tensor using random. Okay. Now let's say I will give T4 is equal to torch dot randin randin, and I will, let's say I'm giving 0 comma 20, and I'm giving something like 5 comma 4. Now what it means? This is how we can create a tensor using randit. Now what it means? 0 is your minimum value, 20 is your upper limit, and 5 comma 4 is your shape of the tensor. Okay, this is what it means. Okay, if you will print this, here you can see we have created a tensor for you. Okay, in 5 comma 4 shape. Here you can see you have 5 rows and 4 columns. Okay, and your lower limit is minimum value is 0 and upper limit is 20. Okay, now let's say I want to create a tensor of zeros. Okay, so simply I can give like T5 is equal to torch dot zeros. Okay, and something like I will do 2 comma 3. Okay, now if you will see your T5, here you can see this is how it looks like. 2 rows, 3 columns. Okay, of zeros. Okay, it is a tensor of zeros. Now let's say you want to create a tensor of ones. Okay, so let's say I will give T6 is equal to torch dot ones, torch dot ones, and something like I will give 2 comma 3. This is I am giving the shape. Okay, this is I am giving the shape, and in this shape I will get the tensor of ones. Okay, if I will show you. And let's say I am giving d type is equal to torch dot int is a data type I want. Okay, so if you will print your T6, here you can see this is a it is a three dimensional tensor filled with ones. Okay, here you can see basically 2 is your number of matrices. You can see there are two number of matrices, 3 rows in each matrix, 3 rows in each matrix you can see, and 4 columns in each row. Here you can see, okay, 4 columns and 3 rows in each matrix. Okay, so this is how we can create torch of ones. Okay, now let's see how we can convert an array into tensor. Okay, now let's see. And first, if you want to check your D type of T6, here you can check like this. Now you want to check its dimension. You can check by dot dim. Okay, now here you can see 3 dimensional. Okay, now let's say I want to check how we can convert an array into a tensor. So first I will import numpy, and using numpy I will create an array. Okay, I have imported numpy, and now let's say I will create an array. Okay, let's say I will give array arr is equal to, let's say I will create array of ones, np dot ones in the dimension of 2 comma 3, 2 comma 3. Okay, now if you will see your array, 2 rows and 3 columns, an array of ones. Okay, now let's say I want to convert this array into tensor. Okay, how we can do that? Simply I will create a new tensor. Let's say t7 is equal to, I will use torch dot tensor, and I will pass my array. What is my array? ARR, right? And if you will see your T7, yeah, this is your tensor. Okay, so this is how we can create tensors. Okay, how we can convert the array into tensors. Now let's discuss in place operator. Okay, let's give a markdown here, in place operator. I will give a markdown here. Okay. Now let's say I will create two new tensors of ones. Okay. Torch dot ones. Okay. Torch dot ones, and I will give suppose size 2 comma 3, and I will give d type as int. Okay. Torch dot int. I want integer data type. Let's say. Okay. And I will print my T8. Here you can see this is how my T8 is looking. Okay, now let's see. I want to create a same thing with new tensor T9. If you will see T8, T9. Okay, now let's say you want to add your T8 and T9 tensor. Okay, how you can do that? Simply like you can create a new variable here. T10 is equal to torch dot add. You can use torch dot add T8 comma T9. Okay. Now if you will print your T10, here you can see this is how you can add your uh, your two tensors. Okay. Now let's say you can add something like this also. T9 dot add slash what you want to add in your T9 tensor. I want to add my T8. Simply you can write T8. Okay. Similarly, you can subtract also. Okay. You can subtract also. For that, you will use T9 dot sub slash what you want to subtract from T9? T8. T8 tensor. Now here you can see. This is how we can use addition and subtraction for our tensors. Okay. Now let's see tensor broadcasting. Okay. I will give a markdown again. Tensor broadcasting. In this addition and subtraction, you can see I had the same shape of both tensors which we are adding and which we are subtracting, right? But you will see the magic of broadcasting where we will have your tensors in different shapes. Okay. For example, I will take a variable, let's say x, and I will create a tensor using torch.empty, and I will give shape of something like 5 comma 3 comma 2 comma 1. Okay, this is my shape. So 5 is 5 number of blocks, 3 is 3 total number of 3 rows, 3 again let's say I will give again, let's say 3. Okay, again 3 number of columns and 1. 1 means values along the last dimension. Okay, so I have created a tensor of x. Okay, if you will see your x, it is looking like this. I will not print this, it is so long. Okay, so this is the shape of x. Now let's create a new tensor again, torch.empty, but this time I will give a different shape. Okay, 1 comma 3 comma 5. Okay, I have given a, and here you can see in 1 comma 3 comma 5, if you will multiply these three, 1 into 3 3 and 3 into 5 15, there will be total 15 number of elements you will have. And here in this, if you will multiply this, 5 into 3 15, 15 into 3 45, 45 into 1 45, means you will have 45 elements in your tensor. In this you have 45 elements, in this you will have 15 elements. Okay, now I want to perform addition for these two. Okay. For example, how we can do z is equal to torch dot add. I will simply give x comma y. Okay. Yeah, but if you will see, shapes of the both tensors are different, right? So how PyTorch is adding them? So this works because of broadcasting. Okay. So if you will check your z dot size, here you can see your size. Okay. So this is how broadcasting works. Okay. Now let's see vector multiplication. Okay. In tensor. Vector multiplication. Okay. I will give a markdown here. Now let's create two tensors. Let's say I'm creating a tensor. A is as torch dot tensor, and here in this, um, let's say I will give some value. Let's say 10 comma 5 comma 5 comma 6 comma 7. Okay. Okay. So I have four values. Okay. I have four values. Here you can see I have one row, only one row, but four columns. Okay. You can say you have one row and four elements. Okay. And also you can say you have one row and four columns. Okay. 10, 5, 5, 6. Okay. Now I will make one more tensor, torch dot tensor, but this time I will give, let's say, 56 comma 100 comma, let's say, 400. 400. Okay. Now in this you can see you have three rows but one column. Okay. If you will print your a comma b, sorry, let's print one by one. Okay. Here you can see this is how my a is looking and this is how my b is looking. Here you can see you have four columns but one row. Here you can see you have three rows but one column. Okay. Now we will perform vector multiplication. Okay. So simply you can use torch dot mul multiplication mul. Okay. Mul, and what you want to multiply a comma b, you want to multiply a and b, right? So if you will print your c, this is how it will look like. Okay. 56 multiplied by 10, this is how it is looking. Okay. So this is how vector multiplication works. Now let's understand transpose. Okay. Transpose. Okay. I will give a markdown here. Now let's say I will make a variable of for containing a tensor. I will make a tensor using randint, and I will give a minimum value as 0 and upper limit as 20, and I will give my shape as 4 comma 5, 4 rows and 5 columns. Okay. If you will print your x1, this is how it is looking, 4 rows and 5 columns. Okay. And if you will print your x1 dot size, it will give you 4 comma 5, right? So now I will use transpose. So basically what transpose will do, it will convert rows into columns and columns into rows. Okay. If, if you will check this, let's say I will create a new variable. Y2 is equal to torch dot. We will use torch dot transpose, and You will give your x1 comma 0 comma 1. Okay, 0 comma 1, 0 comma 1. Okay, if you will print your y2, this is how it is looking. Here you can see now I have four rows, sorry, five rows and four columns. Here you can see I had four rows, five columns. Here I have five rows and four columns, right? So it has converted rows into columns and columns into rows. Okay. If you will print your y2 dot size, it will now give you 5 into 4, 5 comma 4. Okay. So this is how transpose will work. Now let's understand indexing and slicing. Indexing and slicing. Okay. And slicing. I'll give a markdown here. Okay. Now let's see your y2. This is how your y2 is looking. Okay. Now I want to fetch this value. Okay. This value. How you will fetch this? You will simply go for your y2. Your first row means zeroth index. First column means zeroth index dot item. Here you can see you got your first value. Okay. So simply, let's say I will create a new tensor. Let's say T13 torch dot. I will use rand 5 comma 4 comma 7. Let's say, and I will print my T13. So this is how my T13 is looking. Okay. Now, if you want this part only. Okay. So if you will count here 0, 1, 2, 3, 4. Okay. So what you will give T13 and index number 4. Here you can see this fourth block you got. Okay. 0, 1, 2, 3, 4. Indexing always starts with 0. Okay. Remember that 0, 1, 2, 3, 4. Okay. So this block I got this block using fourth index. Okay. Now let's say I want to print this this row of this block. Okay. So what I will do, T13, again I will go for my fourth block. Now, which row I want? Last one. So count 0, 1, 2, 3. Third row, uh, third index row. So I will give third row, third index of my row 0, 1, 2, 3. And okay. Now, if you will see that you got your last record. Okay. Last last row of your block. Okay. Now, you want your last value of your sorry, last row. Okay. You want the last value of your last row. Simply you will go for your again fourth block, third row, and now you want your last value. Okay. Simply you can give -1. Okay. You can give something like 0, 1, 2, 3, 4, 5, 6 also, but if you want this this last value, you can give -1 as well. If you want second last, you can give -2. Okay, you will print this. Here you can see you got your last rows last value. Okay, simply you can do slicing as well, like this. Let's say T13, and I want something like from the first block, and I want these two blocks. Okay. So what you will use? 0, 1, 2, 3. You will use 1 is to 3. Okay, because you want these two blocks, it will start from this and will end on this. Okay. Third, it will not take. Okay. So 1 is to 3. It will be, yeah. Here you can see you got your first index block, second index block. Okay. So this is how slicing works. Now let's discuss reverse indexing. Okay. Reverse indexing. Reverse, reverse indexing. Okay. I will give a markdown here. Okay. Now let's say I am creating a new tensor T14. Okay. So I want to reverse, let's say T13. Okay. This is my T13. I want to reverse this. Okay. So simply what you will use T14 torch dot flip you will use torch dot flip, and you will give your tensor which you want to flip or you want to reverse, and you will give 0 comma 1. So I am reversing the tensor T13 along dimension 0 and 1. Okay, 0 and 1. 0 and 1. If you will print your T14 now, it will something look like this. Okay, here you can see. So this is how it is looking. Here you can see its last record came on the first record. Okay, and its first record came into the last record, right? So this is how reverse indexing works. Okay, simply you can see if you want to check your y2, it is looking like this y2. And let's say I'm creating a new variable y3 is equal to, I will use torch dot flip. Okay, torch dot flip. I will reverse my y2 along along 0 1 axis. Sorry, 0 1 dimension, 0 comma 1 dimension. Now, if you will see your y3, it will look like this. Okay, this last value came at the place of your first value. Okay, and your first value came into the place of last value. So this is how reverse indexing works in tensors. So that is all about tensors. Okay. So that's all in this video. Thank you. So hello guys, welcome to the channel. In this video, we will discuss dataset and transforms in PyTorch. Okay. So first understand what is a dataset. Okay. So in PyTorch, a dataset is an object that stores or provides access to your data and its corresponding labels. Okay. For example, you have a dataset folder. In this dataset folder, you have various images like cat image, dog image, bird image, car image. So this is your dataset folder. Okay. So it is like an object that stores or provide access to your data and its corresponding labels. Means this will provide you the access of these images. Okay. So image will be your input data. Labels means your target or your output, and dataset which manages all images and labels. This dataset. Okay. Which is managing these images of cat, dog, bird, and car, right? So PyTorch provides the dataset class through this line of code. Okay, by this line of code. Okay, you need to you need to go torch in torch.utils.data, and you need to import your dataset. Okay, so why do we need dataset? Okay, so basically, dataset provides a standard way to store data, access individual samples, access labels, apply pre-processing, apply transformations, and work with data loader. Okay, so I have this raw data. I have created a data set. It manages data and labels, then transform. It basically pre-process the data, your data, and then data loader. It creates the batches and shuffle data. It is your model. Okay. Now, PyTorch provides you some built-in data sets. Okay. So PyTorch ecosystem provides many ready-made datasets. Okay. For example, Torch Vision contains datasets such as this MNIST. In this dataset, in this particular dataset, you will have handwritten digits 0 to 9. Okay. This CIFAR 10, you will get 10 classes of color images. Okay. And CIFAR 100, you will get 100 classes of color images. Okay. Now, fashion MNIST, fashion items of 10 classes, okay, and ImageNet. In this is a large scale data set in which you will get 1,000 plus classes, okay. So, so built-in data sets save time and are widely used for research, learning, and real-world applications. Okay, guys. Now let's understand what are transforms. So basically, transforms are operations used to pre-process or modify data before it is given to the model. Okay. First, you can convert image to a tensor. This is your image. We can convert this image into a tensor. Okay. Now, second one is your resize. This is your original and this is your resize. Okay. Third, you can crop. Original will be this, and by cropping your image, the image will look like this. Okay. Now normalize. Okay. You can convert your image into normalized tensors. Okay. Now rotate. This is your original data. You can rotate the your image using transforms. Okay. Flip. Okay. This is your original and this is your flip. Okay. Change brightness. You can change brightness as well. You can see this is your original data set and this is your, it gets brighter a little. Okay. Now, eighth one is your data augmentation. Or this is your original data set, and you can see in this image, you can see augmented samples you will get using transform. So basically, transform helps improve data quality, increase diversity, and make the model more robust. Okay. So this is all about transforms. Okay. Now let's see the difference between dataset versus transform. So basically, dataset which manages data and transform is something which modifies or pre-process the data. It provides samples. It performs operations on samples. Okay. It returns input and label, and it usually operates on input. Okay. It uses LAN and it uses transformation functions or classes. Okay. It uses get item to get the item. It can resize, normalize, and flip etc. Okay. So basically, data set is something which gives you the answer of where is my data, and transform which gives you the answer of like what should I do with my data. Okay. So this is all about data set and transform. Okay. Now let's see data set and transform practically. Okay, guys. We will see data set and transform practically. Okay. So for that, I will import my PyTorch library, import torch, and I will import few things also. Like I will import dataset as well. For torch dot utils dot data import dataset. Okay, dataset. I will import numpy as well, numpy as np, and I will import operating system OS also, and I will import matplotlib library also for plotting graph matplotlib.pyplot as plt. Okay, and then I will import from PIL, I will import image as well. Okay, from PIL import image. Okay, so I will import these things numpy. Okay, I have imported these things, and now we will create a custom PyTorch dataset that will read images from a folder and will allow PyTorch to access those images one at a time. Okay, that first what we will do here. So I have a folder here. I will use this image folder as my data set. And in this folder, I have a image. Okay. So I will try to get this using PyTorch. Okay. So for that, I will make a class. I will make a class custom custom dataset and I will give parameter like self and directory. Okay, these are the parameters I will give. And then I will give self dot directory. Okay. So first what I will do, I will create a init method which will be the constructor of my custom dataset class. Okay. So I will define my init method, and I will here give sorry here I will not give self and directory. I will simply give dataset because I will pass my dataset here. Right. So I will give dataset here, and here I will pass my self and directory parameter. Directory parameter. Okay. Now for directory, I will use self dot directory is equal to directory. Okay. What it will do? It will basically do when we will basically pass image, then self dot directory will contain your images. Okay. So for self dot images, I will use operating system OS library dot list dir, and I will use here my directory. Okay, directory, directory. Okay, so basically OS list dir will give you the names of all the files and folder inside the specified directory. Okay. So and it will be stored in self dot images. Okay. Now what I will do, I will create another method, len method. Okay. Len method. Okay. Len. I will give parameter as self here, self, and I will return my len of self dot images. Len of self dot images. What it will do, it will basically tell you the numbers, how many samples are present in your data set. Okay. For example, in this, I have only one sample present because I have only one image in my folder, right? So I have only one image, so its len will be one. Okay. So uh, I I'm able to recognize one because there is only one image. Okay. Suppose you have thousands of lakhs of images in your data set. How you will recognize? Suppose so it will give you len will give you the total number of samples. Okay. And diff get item. I will create another method. Get item. It will help you it will help you to basically access the image or your data based on the index. Okay. This get item will do the exact things like it will help you to get the data, or you can say your image, any kind of data you want to fetch. It will help you to get this using index. Okay. So I will give image path here. Okay, image path here. So here we will create the complete path of the image. Okay, how we can create? I will give os dot path dot join, and I will give self dot directory and self.images as well, but based on index. Okay, index. Okay, so I have created a class here. Okay, now let's use this. I will create a variable here. Data path is equal to, here I will give the path of my images. Here I have only one image, so I am giving the path. Okay, I will use forward slash instead of backward slash. Okay, I will replace this by slash. Forward slash. Yeah. Okay. Now I will create a new variable here. Data is equal to, and I will use my class custom dataset here. Custom dataset. Custom dataset, and I will give the path. Okay, data path. Here I have my dataset, all the samples. Okay, so I have given data path. Okay, now I will create a new variable data slash length. Okay, now I will give this data dot, and I will try to get this using length. Okay, how many samples are there in my data set? Okay, now if you will see your data slash length, you will get one. Why one? Because I have only one image here. Suppose you have five images here, then you will get five. Okay, so I got one here. You can check this by this method also, in which you will give length and you will give data. Here you can see it has given you one. Okay. Now suppose I want to fetch this data. Okay. Although I have only one image here, so I will try to fetch this using index. Okay. So how you will do this? So what will be the index of this? I have only one image, so first image index will be 0. Indexing number always starts with 0, so its index number will be 0. I will try to fetch this. Okay. So what I will do data dot. I will use get item, and I will give my index number. What is the index number? 0. So to add one more thing here, I will have to give something like image is equal to image dot open, and here I will have to give image slash path. Okay, slash path, and here I will give return image. Okay, so now if I will run this, now here you can see I got my image here. Okay, I got my image here. Now let's say I want to transfer this, like I want to look my image in the form of a graph. Okay, so that's why I have imported uh, matplotlib. So what I will do plt dot im so, and I will give my uh, data dot get item and index number 0. Okay, and I will give plt.show. Now here you can see your image is converted into a graph. So here you can see your image in the form of graph as well. Okay. So that's how we can deal with our data set, how we can read our data set. Okay. Now we will discuss about transforms. Okay. Let's see transform practically. I will give a markdown here. Transforms, transforms. I will give markdown shift plus enter. Okay. Now for transforms, I will import a few things. First, I will go for my torch vision dot transforms as transforms. Okay. Now I will import functional. Okay. I will import functional. I will use dot functional as fn. Okay. As fn. Now I will import two tensor. I will convert the images to tensor. So I will import two tensor. Okay. From torch dot transforms transforms import tensor to tensor, and I will import PIL to tensor also. Okay. From image to tensor I will need to convert, so I will use torch.transforms import PIL to tensor. Okay. I will add PIL here. Okay. Shift plus enter. So for this, I will use a inbuilt dataset. I would like to use torch vision, not only torch vision. Okay. Now for transforms, I will use a inbuilt dataset. Okay. So for that, I will import datasets as well. For torch vision, import datasets. Okay. I have imported this. Now, first I will create a training data. For that, I will make a variable here, training data. Okay. In training data, I will use data sets dot in build data sets. I will use fashion MNIST. I have already discussed about some inbuilt data sets in PyTorch. So I will use fashion MNIST MNIST. Okay. So uh, for that, first I will give root is equal to sorry, root is equal to data. What it means? I'm saying that root is equal to data means this will tell PyTorch where to store the data. So I will store this in the data folder. Okay. So and then I will give train is equal to true because true. I will give a comma here. Train is equal to true. Okay, because this is my training data. That's why I've given train is equal to true. And download is equal to true. Okay, so if there is not any folder or there is no data, so it will download it. Okay, and I will transform transform to tensor. Okay, okay, we will convert image data into basically tensor. Okay, so we will convert the image into tensor. So I will use two tensor. Okay, now uh, let's run this. Now here you can see you have your folder data in which you have the training data. Okay, in this folder you will get your training data. Okay, it is getting downloaded here. It's taking some time. No, it's downloaded. Now let's say you want to see your training data. Let's say you want to see an image. Okay, so you want to see an image. So you will need to use index for fetching your image. Let's say I want to fetch one image. So it will show you the image into the form of tensor because I have transformed the image into tensor. Okay, so it will show you in the form of tensor. So you can access something like this using index like 0, and I will give fourth row. Let's say what it means. First zero means go to the first sample. Then second zero means go to the first channel. Okay. Then sorry, second zero will your first label. Third zero will be your first channel, and it will be your fourth row because its index is third three, so it will consider the fourth row. Okay, I am saying that select the fourth row of first channel image because I have given all the zero here. Okay, so if we will run this, you will get this. Okay, this is your one image. Okay, it has converted into tensor. Okay, so that is a tensor of one image. Okay, and similarly, I will create test data as well. Okay, I will use this one. Okay, so for root again, I will give data in data folder. Download my test data as well. For train, I will give false here because this is my testing data, and download will be true. And let's say I want to show you the image, not tensor. Okay, so I will not transform this. Okay, so if you will run this, okay, you will get your test data. Now, if you want to fetch your test data, let's say give 0. Okay, now let's say I'm creating a variable here, image is equal to, and I will go for my test data and 0, then again 0, and let's say I want to see my image. Here you can see it has given you the your image from fashion MNIST. It is an inbuilt dataset. Okay, so let's say you want to increase the size of your image. Okay, so for that, let's say I'm creating a new variable crop is equal to I will use functional here. Here I have imported functional import torch vision dot transforms functional as fn. So I will use fn as functional. Okay, and dot. Sorry, I will use center crop. I will use center crop, and then I will use my image here, image, and let's say I will use output size as, let's say, I'm giving here, let's say 300. Okay, it will increase your image size. Okay, and I want to see my image. Now you can see here, you can see the bigger image. Okay, here you can see the bigger image, and now, but we need to, I have not used transform here to show you an image instead of tensor, but you are using PyTorch, you need to transform this into a tensor. Okay, so I am transform this. So I will now use transform is equal to, I will use PIL to PIL to tensor. Okay, this time I will use PIL to tensor. Okay, now if you want to see your image, let's say I'm giving image 2 is equal to, image 2 is equal to uh, test data. I will use, let's say, same thing here, test data 0, 0. Okay, I will use same image. Okay, I will use same image. Now, if you will see your image too, this image, this particular image will be converted into tensor. Okay, if you will see here, you can see this image, this particular image has this tensor. Okay, I have transformed the image into tensor, so you can see the tensor of this image. This image has this tensor. Okay, so that is all about in this dataset and transforms video. Thank you. So hello guys, welcome to the channel. In this video, we will discuss autograde in PyTorch. Okay. So what is autograde? Autograde stands for automatic differentiation. Okay. So in PyTorch, autograde automatically calculates derivatives, means your gradients for us. Okay. So this is extremely important when training neural networks, because neural networks learn by calculating gradients and updating their parameters. Okay. So for example, I have this equation y is equal to x square. So the derivative of y is equal to x square will be 2x, right? So suppose if I have x is equal to 3, we have done the calculation. I got the derivative as 6. So manual calculation we will do like this. But PyTorch, but autograde in PyTorch will automatically calculates the gradient, which is 6. Okay. So instead of calculating this manually, PyTorch can calculate it automatically. Okay. So why do we need gradients? So during neural networks training, we generally follow this process. First we will have input, then we will create a model, we will train a model, it will give some prediction, we will calculate loss. For minimizing the loss, we will calculate gradients, and then accordingly we will update the weights to minimize the loss. Okay. So the gradients tells us the model in which direction should I change my weights to reduce this loss. Okay. So it shows the direction and amount of change needed in the weights to minimize the loss. For example, I have loss is 10. I have loss 10 for now. Okay, then we will calculate gradients. So it will compute how to reduce the loss. Okay, then we will accordingly update our weights. We will adjust weights in that direction. Then our new loss, suppose I got our new loss as 7. So our new loss is 7, so it has reduced some error. First I had 10, now I had 7. So this is why gradient, we require gradients. Okay. So there are some functions, important functions to remember. First one is requires slash grade is equal to true. So it basically track operations for gradient. Dot backward, it calculate gradients. Dot grade, access calculated gradient. Grad slash function, functional you can say fn. So it shows the operation that created a tensor. Okay. Dot detach, remove tensor from computational graph. Torch dot no slash grade, it disables gradient tracking temporarily. Then optimizer dot zero slash grade, clear old gradients. Okay. Then optimizer dot step, it update model parameters. Okay. These are the some important functions which we need to remember. Okay. So let's see AutoGrad in PyTorch practically. Okay, so let's see. Now we will see AutoGrad practically. Okay, I have imported PyTorch here, import torch. Now what I will do, I will make a tensor. Let's say in x variable, I will make a tensor torch dot tensor torch dot tensor, and I will give, let's say 7. Okay, 7.0, and I will give requires grade is equal to true. Okay, I will give this. Now, requires grade is equal to true means what I am saying is I am saying keep track of the operations performed on X because later I want to calculate its gradient. Okay, that's what I am saying by doing by giving requires grade is equal to true. Okay, now let's say let's perform some operations on X. Let's say I have created a new variable f. Now let's say I want to perform an operation like x is square plus 3. So so how we can do x square plus 3? X square plus 3, right? So I have performed an operation. So x square plus 3 means 7 square will be x value is 7, so it will be 7 square uh, is 49 and plus 3 will be 52. So its value, f's value will be 42. If you will see your f, here you can see 52. So here you can see grade slash fn. What it means. So PyTorch is telling us I know how this tensor was created. So this is what PyTorch is telling us. I know how this tensor was created. How this tensor was created. I have stored the necessary information to calculate gradients backward. Okay. So that is what it is telling me by giving grade slash fn. Okay. Okay. Add backward. Okay. So this is what PyTorch is telling us. Now, if you will do f dot backward, f sorry, backward, f dot backward. Now what it is saying, dot backward which tells AutoGrid go backward through the computational graph and calculate the gradients. Okay, calculate the gradients. X square plus 3. So x square plus 3's derivative will be 2x, right? X square plus 3's derivative will be 2x. So what is the value of x here? 7. So what will be the derivative of x square plus 3 will be 2x. So 2 into 7 will be 14, right? So how we can access the gradient? Simply I can do x dot grade. Now you will get 14. Okay. Understood how it works? Now let's take another example. Okay. Let's say again I will create a variable and I will store a tensor. This time I am creating a tensor like this. Let's say 1.0, 2.0, 3.0. Okay. And similarly, I will give two more lists here. 4, 5, 6, 7, 8, 9. Okay. So I will replace this by 4, 5, 6. Okay. Now, again, I will make another. Sorry. I will. Okay. I will replace this by 7, 8, and 9. Okay. If you will see your Y here. Okay. So it will, if you will see your Y here, it is looking like this. I have created a tensor for Y. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. Now, again, I will perform an operation on it. Okay. What I will do, again, I will create a variable here. Let's say f2 is equal to, let's say f2 is equal to y square plus 3. Same equation. Okay. Y square plus 3. Okay. If you will see your f2 here, what it will give you? 1 square will be 1 plus 3, 4. Its square will be 4 plus 3, 7. 3 square will be 9 plus 12. So it will give you like this. Yeah, 4, 7, 12, 19, 28. Okay. According to this equation, it will square each element and then it will add plus 3. Okay. So this is how your F2 is looking. So now what I will do, I will make sum of every element. Okay. Uh, I will add all the elements to make this into a single value. Okay. So we will do the sum for converting the entire matrix into one number. Okay. Because without specifying an external gradient is normally used when the output is scalar. Okay. So if it will be a single value, then it will considered as scalar. Okay. So so what I will do, I will do z is equal to, let's say, f2 dot sum, f2 dot sum. Okay. And if you will see your z here, it will it will add your all elements. Okay. It will add your all elements. Let's see what you will get. You will got 312. If you will add all these elements, you will get 312. Okay. Now, again, what I will do, I will do y dot, sorry, not first, I will do z dot backward. Okay. Z dot backward. Okay. So I forgot to give your requires grade is equal to true. Okay. Okay. Now it has given again grade functional. Okay. Say for same purpose like the previous one. I will do z dot backward again for same purpose like before. Now, if you will see your, if you want to access your gradient, what you will do, y dot grade, simple. Here you can see this is your gradient. So if you will if you will do derivative of this equation, y square plus 3, again you will get 2y, 2 into y, right? If you will do derivative, if you will find derivative of this equation y square plus 3, you will find 2y, right? So what will be the value of 2y? This is your y. So multiply all the elements here by 2, right? 2y means multiply 2, multiply y by 2. This is your y, and multiply this by 2. So 1 is replaced by 2, 2 is replaced by 4, 6, 8. 12, 10, 12, 14, 16, 18. Right. So this is how autograde works. Okay. So that is all in this video. Thank you. Hello guys, welcome to the channel. Today we are going to discuss optimizer in PyTorch. Okay. So what is an optimizer? So an optimizer is the part of a neural network that helps the model improve its predictions by updating its parameters. Parameters means its weights and biases. Okay, so every input has some weights. Okay, so it helps to basically improve the prediction of the model by updating the parameters of inputs. For example, weights and biases. Okay, so in simple words, the optimizer decides how the weights and bias should change so that the model makes fewer mistakes. Okay. For example, we have given an input to the neural network. So our actual prediction was 70, but I'm getting actual value as 100. So it means that our model is making mistake. Okay. So basically, how does the optimizer help? So the optimizer adjusts the weights and biases, okay, on the mistake means error, so that the next prediction is closer to the actual value. Okay. For example, I have this current prediction as 70. Now I have adjusted the weights and biases using optimizer. Now our next prediction is got 90. Okay. So it is closer to 100. So this is how actually optimizer works. Okay. This is very simple words. In very simple words, I have explained. Okay, so this is what optimizer is. Okay, now let's understand how actually neural network learns. Okay, neural network in the learning process. Okay, so this is a kind of neural network. Okay, where I have input layer, I have hidden layers, then output layer, then I'm getting the predictions. Okay, so first is your input data enters the neural network. I'm giving the input to the neural networks. Then neural network means forward path. So here input passes through layers and connections to produce the predictions. Okay. So here our input is passing through our layers, hidden layers, okay, hidden layers and connections. You can see this to give the prediction. Okay, now third one is your prediction. So the network outputs a prediction. Okay, so we got our prediction now. Okay, now loss. Fourth one is your loss. So I know what is my exact prediction. Okay, what is my actual prediction, and I got my prediction as well. So what we will do, we will compare this prediction which I got from training this model, by training this neural network, and my actual prediction. So that difference will be your loss, right? then our next then our next thing will be back propagation. So error will be here in back propagation. Error will be sent to backward through the network to compute gradients. So what is gradient? So gradients tells how much each weight contributed to the error. Okay, means how much each input have its own weight. So it will tell me how much each weight contributed to the error, which is my difference between my prediction uh, by our neural network and my actual prediction. Okay, now next thing will be your back propagation. Again, backward pass. So here gradients flow backward from output to input, from output to input, not from input to output. This time output to input. Okay, next thing will be your optimizer. So optimizer uses the gradients to update weights and biases. Okay, so that our model gets better prediction. So that our model will give better prediction. Now, but after this, it will update weights and update it. weights are updated to reduce loss. Okay, using optimizer. Now, neural network learns with new weights, the network makes better predictions. Okay, so this is how neural network learns. Okay, this is the basic idea of how neural network learns. Okay, now why do we need different optimizers? Now, if you might ask, if gradient descent works, why do we need different optimizers? So because neural networks can be complicated. So different models and datasets can have different training behaviors, right? You can have multiple datasets, different datasets. So every dataset will have their own behavior, okay? Not a same behavior, okay? So a basic optimizer might learn slowly, get unstable, struggle with certain parameters and directions, require careful learning rate tuning, right? So we have some popular ones. So we have some popular optimizers. First one is your SGD. So the most basic optimizer, this is SGD, updates parameters using only the current gradient. Okay. Next is your momentum. It uses past gradients to build momentum in the right direction and produce oscillations. Okay. It is faster and more stable than vanilla SGD. Okay. Next is your RMS prop. It adapts the learning rate for each parameter based on the history of gradients. Okay. It works well for non-stationary or noisy problems. Okay. Next one is your Adam. Adam is the most currently used optimizers. Okay. So it combines momentum and RMS prop ideas, adapts learning rates, and uses momentum. Okay. So it is very popular and works well in many cases. So we generally use Adam optimize. Okay. Next is your Adam W. It it is an improved version of Adam with decoupled weight decay for better generalization. So it is widely used in modern deep learning. Okay, so this is all about optimizers in theory. Now what we will do, we will build a basic neural network and we will understand how we can use our optimizers. Okay, guys. So let's see how we can build a neural network and how we can use optimizers. Okay. So let's see. So now we will build a basic neural networks and I have this dataset of iris dataset where I have the output of species. I have three categories in my species, Setosa, versicolor, and virginica. Okay, and these are its inputs, means these are its features. Okay, so we will train a basic neural network and we will understand optimizers. Okay, so I've imported torch here and now I will import some more basic things. NumPy as NP. I will import NumPy. I will import pandas as well. Pandas as PD. I will import from torch dot utils dot data uh, data data. I will import tensor dataset. Okay, and then I will import random split as well. I will import random split, random split, and from torch I will import NN neural network as well, and then from torch dot NN I will import functional. Functional I will import as F, and then I will import train test split from sklearn dot model selection dot model selection import train test split. I will import all these things. Okay, it will take some time to import. Yeah, I imported all these things. Now what I will do, we will create our own neural network class. Okay, so I have a iris data set. So let's say I will create our own neural network class as, let's say, iris nn. Okay, iris nn, and then I will give the parameter as nn dot module. So what is nn dot module? NN dot module is basically a base class provided by PyTorch for creating neural networks. Okay, so I will import this. Now I will define a constructor class. Constructor class define in it. This is my constructor class. Okay, I will give self parameter. Okay, now I will give super, then init and so basically, uh, this super init class basically initializes the parent class. This is your parent class nn dot module. It will initialize by this. Okay. So now what I will do, I will create my first layer self dot fc1 is equal to, I will use nn dot linear, and I will give 4 comma 16 means 4 input features and 16 neurons in the layer, in the first layer. Okay. Now, in the same way, I will create a second layer. FC2 is equal to nn dot linear. I will create nn dot linear. Now, I will give 16 to 8 neurons. Okay, 16 to 8 neurons. Okay. Now, similarly, I will create third layer. FC3 is equal to nn dot linear. Okay, nn dot linear, and I will give 8 comma 3, from 8 neurons to 3. Basically, in this iris dataset, I will have 3 classes here. If I will show you, control shift plus L, you can see you have only 3 classes: Setosa, Color, and Virginica. Okay, so that is why I have given 3 here. Okay, now in the same way, this time I will define a forward class. Okay, so this will basically define how the data moves through your network. Okay, for that I will create a new. I will define a new class here, new method here. I will give self parameter and x. X will be your input. Okay, x will be your input. So I will give x is equal to torch dot. I will use ReLU activation function. ReLU's activation function, it's has a ReLU activation function has a range of 0 to x. Means if I will get values in negative number, then it will convert, ReLU activation function will convert that into 0. That particular negative values. Positive will remain same, but negative values, it will ReLU activation function will convert into 0. Okay, because its range is 0 to x. Okay, it doesn't contain negative numbers. So I will use self dot fc1 first layer. So input will go through the first layer, and the layer performs something like Z is equal to X W plus B, where X is your input, W is your weight of the input, and plus B is your plus bias. Okay. So in the same way, I will give this for second layer as well. Torch dot use ReLU activation function and then self dot FC2, and then at the end our third layer self dot FC3. Okay, here I will give X. Now, now I will give return X. Return X means return my input. Okay, okay, capital M. Okay, now what I will do, I will fix the seed. Okay, seed means I will explain. Dot manual manual slash seed. I will fix this by 41, which means why I am fixing our manual seed here, because without fixing the manual seed, you will get different initial weights each time you will run the code. Okay, suppose you cut this and again you came to this Jupyter notebook and then you will again run the code, then you will get different initial weights. Okay, but after fixing this you will get same initial weights. Okay, so I will run this. Okay, so it has fixed this. Now I will create a object here to call our iris nn class. Okay, which I have built. Okay, now, okay, so I will not use small l, I will use capital L. Okay. Now, now I will import my dataset, iris dataset. Okay, because I am giving that as an input to my neural network. I have built my neural network, so I will give this read slash CSV. I have CSV file of iris. Here is my file. Copy path, paste it here. Okay, and if you want to see your shape of the data, you can check that by this. Okay, you have 150 comma 5. Okay, means 5 columns and 150 rows you have. Okay, and if you want to check your first 5 rows, you can check this by df.head. You can see that. Okay, this is your starting 5 rows. And now what I will do, I have three classes here, Setosa, Versicolor, and Virginica. Okay, so what I will do, it will not take this character type input. What I will do, I will map this Setosa as 0.0, Versicolor as 1.0, and Virginica as 2.0. Okay, so what I will do here, I will call my df, and in df I will call my species because I need to perform on my species. Okay, so I will again go for df dot species dot map, and in the curly braces what I will give, I will give my setosa as 0.0, comma, my second class is versicolor, versicolor. Okay. So what I will give as it is I will assign this as 1.0 and then I will give Virginica as 2.0. Okay. Now if you will check your df dot head now, it will give you, yeah, you can see that Setosa is converted as 0.0, okay, and versicolor Virginica also 1.0 and 2.0. It gets converted, okay. So now what I will do, suppose I want to check in df.info. Uh, you can see every value has data type as float, okay. Now what I will do, I will take all the input features till pedal width into x, and in y variable I will take my output column. Okay. So what I will do, I will do x is equal to df dot drop, means give me the complete df but drop one column, that is my species. Okay, species as x is equal to 1. Okay. So by doing this, I will get all my input features still pedal width. I have dropped spaces, so I will not get spaces in my in my x. So in y, I will take my spaces only. So I will go for my df spaces. Okay. Now I have x and y separated. I will assign this as x is equal to x dot values, y is equal to y dot values. Okay. Now I will split the data set. I will split the data set into training and testing. Okay. That's why I have imported train test split. So what I will do, I will take four variables here, x train, x test, y train, y test is equal to, now I will call my train test split and I will give my variables x comma y, because in my x and y columns I have my input features and output features, right? So and then I will give train size as, train size is equal to 0.75. Means what I'm saying, I will split the data set as 75% for my training and 20 remaining 25% for will be for my testing. Okay. And random state, I will give this as, let's say, 100. Random state is equal to 100. Okay. Now my data gets divided into training and testing. Okay. Now what I will do, now I have four variables, x train, x test, y train, y test. Okay. So what I will do, I will convert the tensor of x train and x test into float, and I will convert the y train and y test tensor in integer. Okay. So how we can do that, train, x train is equal to torch dot float tensor. That's it. Okay. And I will give x train here, x train. Okay. Similarly, I will use this for all four variables, x train, x test, y train, and y test. Okay. Y test. And here I will give x test. Here I will give y train. Here I will give y test. Okay. Y test. Okay. So I am converting x train, x test into floating point values, and y train and y test in integer point values. Okay, so how we can convert this into integer point values? So simply I will use long, long tensor. Okay, long tensor. Again, long tensor. Okay. Now what I will do? I will create a loss function. Okay, let's say I'm creating a new variable criterion. Okay, criterion. I'm uh, creating a loss function here. Let's say I will use nn dot cross cross entropy 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 loss. Okay, so I'm creating a loss function, and now I am uh, giving an optimizer. Let's say I'm creating a new variable optimizer is equal to now I'm giving a optimizer. Okay, I'm using optimizer torch dot optim, and now I have to give the name of my optimizer. There are some optimizers I have like Adam, RMS prop, momentum, SGD. So let's say I want to use Adam. Okay, Adam, let's say you want to use SGDs. Only give SGD here. If you want to use RMS prop, then you need to give RMS prop. Okay, so that's how you can give the name of the optimizer, whatever optimizer you want to use according to your need. Okay, so I will give here model dot parameters. Okay, parameters, parameters. Okay, so what I'm saying here by giving model dot parameters here, I'm saying so model dot parameters basically uh, give the basically give gives the optimizer all the trainable parameters of neural network. Okay, it will give all the trainable parameters to the optimizer of neural network. Okay, by model dot parameters. Okay, now what I will use a learning rate. Okay, so I will use 1e minus 3. 1e minus 3 is nothing but your 0.001. Okay, so I'm giving it as a learning rate 1e minus 3. Okay, I will run this. Now, now if you want to see your outputs, simply I will create a new variable outputs. Simply I will use model dot forward, and here I will give x string. So I want to see the output on my X string. So simply if you will see outputs here, okay. So here I need to give a here I need to give X. Okay. FC1 X. Here I need to give X. Okay. Now if you will run this, okay. Now you can see all your outputs here. Here you can see all the outputs. Okay. So hello guys, welcome to the channel. Today we are going to discuss backpropagation PyTorch. Okay. So what is backpropagation? So backpropagation is the process used by a neural network to calculate how much each weight and bias contributed to the final error. Okay. So in simple words, backpropagation works backward from the loss and calculates gradients for the model's parameters. Okay. So the complete flow is like this. You have given input to the neural network. Third, it has given you prediction. Then you calculated the loss, which is your difference between the actual value and your prediction. Okay. Then backward propagation works backward. Okay. Backward from loss back through the network. From loss through the network. Okay. It will work through backward. Okay. From loss to the network. From loss to the network. Okay. So it calculates how much each weight and bias contributed to the error. Okay. Now, sixth is your gradients. So, gradients for each weight and bias. Okay. So, what is the what should be the weight or and what should be the bias for each input? Okay. Now, next is your optimizer. Uses gradients to update a parameter like I have already explained LGD, ADAM, RMS prop in our previous video. Now, eighth one is your we will get our updated weights. Okay, weights and bias gets updated to basically make the model better. Okay, so it will get repeated for many iterations until the model learns. Okay, so this is something about back propagation. Okay, so why do we need back propagation basically? So suppose model I have a model prediction where I had actual value is 100 and I got 70. So model is making error, right? So we have calculated loss, we got 30, right? So the problem is the neural network may have thousands or millions of parameters, weight 1, weight 2, weight 3, like billions. So we need to know which weights contributed to the error and by how much. Okay, so the solution will be back propagation helps us to determine which weights contributed to the error and by how much. So then back propagation calculate gradients for each weight telling us how much each weight affected to the loss. Okay, so in short, back propagation tells us how each parameter is responsible for the error. Okay, so the optimizer can update them and make the model better. Okay, so what actually back propagation calculates? So back propagation basically calculates gradients. Okay. So a gradient tells us how much the loss changes when a parameter changes. Okay. For example, I have weight A. I have gradient 0.8 for weight A. Then weight B, I have gradient minus 0.2. Weight C, I have gradient 0.05. So each gradient tells us how sensitive the loss is to that parameter. So this information is then given to the optimizer. Okay. Then loss basically measures how much the wrong prediction is. Back propagation works backward from the loss and calculates gradients. Then what is gradients? Is basically tells you how much each weight parameter contributed to the loss. Okay. Optimizer, it uses that gradients to update the parameters. Okay. And updated lastly, we will get updated weights. Parameters are updated to reduce the loss. Okay, so it will basically helps the optimizer to get better weight for each input which is contributing to our loss. Okay, so this is something about back propagation. Now let's understand how actually back propagation works. Okay, previous video, we built a basic neural network and we have given iris dataset as our input and we predicted our output as well. Okay, so first I had a mistake here. Versionica, not it's E, not it's not E, it's Versionica. So now what I will do, I will rerun. Okay, I will rerun all the cells. Okay, so now, if you will check your loss, if you will check your loss, so let's create a variable loss. Now you want to check what loss is coming for this neural network. I will use my loss function criterion, okay, which I have already declared here, criterion, okay. So I will use my criterion and I want to figure out what is the difference between my actual value and predicted value? That's how we calculate loss. So our predicted value is our outputs, right? Outputs is my predicted value, and my actual value is y train. So I will give my outputs, and I will give my y train. Okay, y train. Okay. So uh, now if you will check your loss, you will get 1.1146. Okay, so this is what loss is coming 1.1146. Now using back propagation, now you in this video we will use back propagation to reduce this loss. Okay, to reduce this loss, let's see how we can use back propagation and we can reduce the loss. Okay, so simply, first, what I will do, I will create a empty list, losses, let's say, and I will give epochs is equal to, let's say, 1000. I'm saying that train for 1000 epochs. Okay. Now, I will apply a for loop here for epoch. Let's say I'm giving a variable epoch in range epochs. Epochs has a range of 1000, right? Epochs. What I will do, I will give my outputs here. First, I will give my outputs here, outputs, and I will give my model forward, model dot forward, and I will give my X train. Okay, I'm saying this is the like forward pass. The X train will be passed through the neural network. So I'm giving X train here, X train, and then I will apply my optimizer as zero grade, zero grade means I'm saying that clear the gradients from the previous iteration. That's what I'm saying here. Optimizer is equal to zero grade, and now I'm applying my back propagation. Loss dot backward. Okay, that's what I'm saying here. Now next thing I will say optimizer dot step means, let's say I'm giving optimizer dot step. Okay, I'm saying that use the gradients that were just calculated to update the model's weight and bias. Okay, that's what I'm saying here. Use the gradient that were just calculated to update the model's weight and bias. Okay, now lastly, I will append my losses, which is my empty list I have created here. Losses dot append, and I will give my dot loss dot item. Okay, that's what I will give, and I will say now we will check for every 10 inputs, not all 1000 inputs. I will not get 1000 inputs. I want only 100 inputs. So I want to see I want to check for every 10 inputs. So what I will do, I will give if epoch plus one, because epoch always start with 0%, is 10, which will be my reminder, equals to 0 means my remainder should be 0. Then I will print my epochs and loss. So I will use my f string here, and I will say, let's say epoch, and in this what I will give, this time I will give my epoch minus one divided by divided by my epoch. Okay, epoch. Okay, and also comma, and I will show my loss as well. Loss will be my square braces. Loss dot item. I will use this. Loss dot item, right? Loss dot item dot. Let's say I will use 4f. 4f means display the number with 4 digits with decimal points. Okay, I'm saying that display the number with 4 digits with decimal points. Okay, so it will show the 4 digits. Okay, this is what I'm saying here. Let's run this. Now, as you can know this, I have to add this here, and I need to use dot. Okay, I have to add here. I forgot to add loss here. I need to use. I need to add loss as well. So I will simply use this outputs and white range comparison. Okay. So then I need to add here +1. Okay, not -1. So I will not use equal to. I will use optimizer dot zero growth. Okay. Now you can see here loss. You can see your loss here. So yeah, first check the loss. What loss we were getting? 1.1146, right? Now I use this code. I use backpropagation, and then now look at your loss. 0.0635. Previously I had 1.1146. Now I have 0.0635. Okay, so that is how backpropagation works. And this is how we can reduce our loss. Okay, so that is all about in this video. Thank you.